All right, today we're going to dive into some truly groundbreaking research that might just flip our entire understanding of Alzheimer's right on its head. It's a fascinating story about a very simple, very familiar element that could be hiding a huge secret to protecting our brains. And it all kicks off with one really important question.
And that question right there is really the heart of this whole thing. For decades, for so long, the focus has been on this toxic buildup of proteins in the brain. But what if the real story, or at least a massive part of it, is about a deficiency? What if it's about something being stolen from the brain? Now, to really get why this new perspective is such a potential game changer, we first have to appreciate the enormous challenge that we're all facing with this disease. The sheer scale of Alzheimer's is just staggering. It makes up the vast majority of all dementia cases. We're talking 60 to 80%. This affects millions and millions of people, taking away their memories, their ability to think, and eventually their independence. And here's the really tough part. After decades of intense research, the therapies we have right now, they only offer pretty modest benefits. And sometimes they come with some really serious risks. So you can imagine the entire scientific community and, of course, families everywhere are desperately looking for a different way to fight back. And that brings us to our story. It really is like a scientific detective case. And the main clue? It's something you've absolutely heard of, but I bet you haven't thought about it in this context.
That's right, lithium. Not some super complicated lab-designed molecule, but one of the simplest elements you can find on the periodic table. It's naturally in our environment and even in tiny little traces in the water we drink.
So this was the first huge clue. Back in 2017, a massive study in Denmark looked at the health records of over 800,000 people. And what they found was pretty remarkable. As this quote highlights, the areas where people had higher long-term levels of lithium in their drinking water also had a lower rate of dementia. Now, this wasn't totally out of left field for scientists. They already knew that lithium has some pretty cool brain-protecting powers. One of the key ones is that it slams the brakes on an enzyme called GSK3. And you can think of GSK3 as the accelerator pedal for all those toxic proteins that clog up the brain in Alzheimer's. Okay, but this is where the plot really thickens. If lithium is so protective, then what's happening to it in the brains of people with Alzheimer's? Researchers at Harvard went looking for the smoking gun. And get this is what's so wild. They measured 27 different metals, zinc, copper, iron, the whole shebang. And the only one that was consistently and significantly lower in the brains of people with both early and late-stage Alzheimer's was lithium. Just lithium. And that created this fantastic mystery, right? Because when they checked, the lithium levels in the patient's blood were totally normal. So it wasn't a problem of getting it into the body. The problem was happening inside the brain. So where was it all going? And this image shows the stunning answer. Using some really advanced imaging, they found the missing lithium. You see those bright pink areas? That's the lithium. And look where it is. It's concentrated and literally trapped right inside those dense blue clumps of amyloid plaque, the very hallmark of the disease. So the researchers gave this a name, amyloid sequestration. The plaques aren't just these passive blobs sitting there. They're active thieves. They're trapping and hoarding this vital element, effectively robbing the surrounding brain cells and starving them of a nutrient they desperately need. So if this amyloid theft is the problem, the next logical question is, what happens if you make lithium even harder to find? Well, they tested this in mouse models of Alzheimer's by putting them on a diet with almost no lithium, and the results were just devastating. Every key sign of the disease got worse faster. More amyloid, more inflammation, and a quicker cognitive decline. It just confirmed how absolutely critical this missing lithium is. So what they uncovered is this really nasty, destructive feedback loop, a vicious cycle. It starts when the plaques trap lithium. That creates the deficiency, which then takes the brakes off that accelerator enzyme, GSK3. That enzyme then kicks into overdrive, making even more amyloid and tau tangles, which causes more damage and makes the cognitive decline speed up. It's like the disease is literally feeding itself. Okay, so if the problem is a thief, how do you stop it? Well, maybe you don't fight it head on. Maybe you outsmart it. And this led the researchers to a really brilliant idea. So here's the thinking. The amyloid plaques have a negative charge, and the lithium ions have a positive charge. Opposites attract, right? The plaques are basically like tiny magnets for lithium. So the researchers thought, what if we used a form of lithium that's Well, less magnetic. They compared the standard prescription kind, lithium carbonate, to an organic salt called lithium orotate. And as you can see, the orotate form just doesn't ionize as much, which in theory should make it less sticky. And yep, their hunch was spot on. Now, this chart looks a little complex, but the story it tells is actually really simple. The key is seeing how low those blue data points are. That lower conductivity means the lithium orotate is releasing fewer charged ions. It confirms that it is in fact less sticky and way less likely to get snagged by those amyloid plaque magnets. So when they tested this in mice, the results were, well, they were remarkable. Low-dose lithium orotate didn't just work a little better, it dramatically outperformed the standard lithium carbonate. It was better at preventing the buildup of junk in the brain, better at protecting memory, better at calming inflammation, and it even helped the brain's own immune cells get back to doing their job of cleaning things up. So let's just pull back for a second. What does all of this actually mean? It really represents a fundamental shift in how we might need to think about Alzheimer's disease. And this right here is the absolute key takeaway. For maybe the first time, we have really compelling evidence that we should be looking at Alzheimer's as a deficiency disease. The problem isn't just the presence of something toxic, it's also the absence of something protective. And that realization just blows the doors wide open for a completely new path for prevention and treatment. Instead of just trying to blast away the plaques, what if we could safely and smartly replenish the brain's lost lithium, using a form that can actually sneak past that amyloid trap? This quote from an expert in Nature really captures the hope of this discovery perfectly. No, it's not a cure just yet, but it is a powerful, profound, and honestly, very exciting new angle. And it really leaves you with a critical question, doesn't it? What other simple, essential nutrients might we be overlooking in our fight against the most complex diseases of the brain?